Assalamualaikum warahmatullahi wabarakatuh. Ini Muhammad Zahab dari Mobile Zaman CE20107. So I will explain about question number one from group 7. For the question number one, 1A, we need to derive all the possible child expression with suitable Q diagram. So using this is my equation, which is using tree diagram, we can determine all the possible chain to derive, which is I have 12. After I derive all the equation, for dw over dx I get equal to 2x, dw over dy equal to 2y, dw over dz equal to 2z, dx over dt equal to 0, dz over dt equal to 0, dx over dr equal to cos theta, dy over dt equal to 0, dy over dq equal to r squared sin theta, dy over dr equal to 2qr sin theta, dz over dt equal to 1 over q square root p, dz over dt equal to 0, and finally dz over dr equal to 0. And so for the question 1A2, we need to find, second moment, we need to find the dw over dr. So based on our derivation, we can find the dw over dr, which is first we need to times dw over dx times dx over dr plus dw over dy times dy over dr, and plus uh, d over dz times dz over dr. dw over dz times dz over dr. So from the calculation we will get 2r cos squared theta plus 4q squared r power of 3 sine squared theta. And so for the question B, we need to define as a function of xy to determine dz over dy for the equation B. So from the equation, first we need to arrange the position, which is to the left and equal to 0. And after that, we need to divide into two parts, which is y with y and z with z. And finally, we can get the answer by differentiate dy over dz, and we will get the answer, which is negative 5z squared minus x plus 2x divided by 12x squared z squared minus 10yz minus 2. And finally, for the question C, which is to determine the area of region R and determine the surface area of position hemisphere by using double integral. So first, we need to factorize the equation, and we will get the answer, which is x equal to -1 and 2. Then by using the integral, we will get the y is equal to 1 and y equal to 4. So after we insert the value, and using double integral, which is -1 over 2 and 2 plus x over 2, 2 over -1 and 5 minus times x minus 1 square to 2 plus x, and finally the answer we will get 4.5 units square, which is 9. If we calculate, the answer is 9 over 2. And then we can build a graph, and the answer will be like this, which is the midpoint is the position -1 and 1 and 2 4. For the question C, development, we need to find the upper hemisphere, which is the formula is z equal to square root 1 minus x squared minus y squared. But from the equation, we will get the radius is 2. So from the equation, we can define the third expression, which is z squared equal to 4 minus x squared minus y squared. And first, from the first obtain, first we need to integrate the from the equation, and finally we will get the which is the integrate is r over square root 4 minus x squared minus y squared. So if the equation is 0 similar or less than z squared, less than or similar than 1, then we can assume from the equation to get finally to get 2 is uh, larger or similar than r and larger or similar than square root 2. So from the calculate equation, which is the integrated equation that we did before, and also x we can change the x squared minus y squared into r squared, which is we will get like that right here. So we just integrate the equation for 2 integrate 2 into integrate square root 3 into 2, then we will get the answer is E. So it means that negative 2 is equal to 2, which is negative to r is equal to 2t, which is r is equal to negative t. So we just insert the value in the equation, then negative t over t, and then we just insert the integrate, which is 0 from the given equation, which is 0 and 1. Then we integrate the equation, and finally we will get the answer, which is pi over 2 unit square. So now I will compare my equation with MATLAB. So for the question number 1, we need to derive all the equation. And as the command window, we can see this is all the answer similar to our manual calculation. Just to x, to x, to y, to z, 0, 0, cos theta, 0, r squared sin theta, 0, similar to from our manual calculation. So we will move to the second question, which is question number 1A, development. As you can see from the command window, also we get the same answer, which is negative 5z squared plus x minus 2xy divided by negative 12x squared z squared plus 10yz plus 3. And next we will move to the question C. To get the region, which is the graph also similar. And the area also will get 9 over 2, which is 4.5 meters square. And finally, for the question number 1, C development, the final answer which is pi over 2, pi over 2 units square. And from the question, first we need to find the x squared, which is we will change to z over the x squared. Also y squared we change to z over the y squared, and then we will get the equation which is r over 4 minus r squared times 1 over 2. So then by integrate the equation, as you can see, equation by integrate the equation, you will get the final answer similar to our final calculation. So that's all from me for question number 1. Thank you.
Assalamualaikum. My name is Amirul Adam bin Masha. My matric number is CE210138. So, I would like to present my question 2. So, for the question 2, here's the manual calculations. So, we need to find the maximum limit first, and then we substitute into the integrate. And then here's the answer. For the next one, question B, I'm using the same method, and then we got the 18 unit power of 3. So for the next one is question C. Uh, we use integrate for the plotting, and then we substitute the answer on the formula equations, and then the answer is 10.8313 G. Okay, for the next one is maximum limit. This is for a maximum limit. So I'm sorry. For the next one is type calculation. So here's, and then MATLAB simulate. For the first question here, we will use the codings. We put the equation here, and then uh, we we did we put the maximum limit z equal by square root a power of 2 and minus x power of 2, and then equal by a. Same goes to the second one, x square root a power of 2 and minus z power of 2 equal by a. And then the next one is y equal x, and then um, x equal 1. So we integrate the equation here, and then we put the temporary for integrate for the first what we call it, equations. I'm so sorry. Yes, equation. Expression. My bad. Sorry. And then we put until for temporary, and then we run, and then the answer is a power of 2 for the dz dx, for the dz dy dx, and then for the expression in dz dx dy is a power of 2, same goes to the dy dz dx a power of 2, and then the last is dy dx dz. The answer is a power of 2. For the B, we calculate the volume of curve waste cut, then the answer is 18. Same with the manual calculations. So display is to stand for the I'm so sorry, display for the value of the curve wage cut in unit power of 3. We must put it on this, and then that's why here there will be appear as a volume, the title. So we put the equation here. Then the next one for the x axis, the y axis, and then we got the answer here. So for the next one is question C. So I put the equation here and then substitute to the limited character on the MATLAB, because MATLAB can read um, specifically, so we need to clear as 3000 as a T3K in engineering symbol. So the symbol is not the symbol, sorry. We got temporary here to calculate, and then display as a declare mass of envelope solid in unit 3, unit power of 3. And then we got the answer here, negative 4 pi square root 2 minus 4 by divide of 3. Okay. So for the 3D graph for the 2A is here. We will get the model like this. The second one, we get the model like this, and then for the last one, we will get for the like this, the model. But here the detail, as you can see here, we got the hemisphere before the -2 and after the 2 on the x-axis. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Yasir bin Osman. My number is CE21006. I will continue explain for the question 3. So for the question 3A, there was not necessary for the MATLAB method. So for the question 3A, we have to state the three physical interpretation of the divergence and explain what the amount of work done by the force field F. So for the question 3A, one Roman is state the three physical interpretations of divergence with a sketch of the vector fields. So for the answer is, so this is the answer for question 3A1 Romans. So the first is divergence measure how much the fluid I is expanding, and the second divergence given you the power to determine the number of source or sink in your system, and then in the theory of divergence, source rate amount of the fluid added to the system per unit time in the authorized area, and for the divergence of the function is f equal to d over dx fx plus d over dy fyj plus d over dz k. The last is three physical interpretation of the divergent and respective field. So this is the positive divergent. So and then the second one is negative divergent, and this is the zero divergence. And for the question 3A to Romans, the question is we have to explain why the amount of work done by the force field F bracket xy equal to yi plus bracket s plus 2y J, to move a particle from point A to point B is the same for two different paths. So the answer is, this is the answer for the question 3A2 Roman. The first is, let's A and B two point and it has a two different path APB and the other AQB. The second is force field F bracket xy equal to yi plus s plus 2yg. So this is the work done in the moving particle from point A to point B, which is W equal to F dr. The third is, if a particle taken from point A to point B through path APB, so work done, so W equal to integrate BA APB yi plus x plus 2yj dr. So if the particle taken from point A to point B through path AQB, so work done, W equal to integrate BA QB bracket yi plus x plus 2yj dr. The last is, if force equal to conservative, so work done by force field F moving particle from point A to point B for two different paths equal to integrate BA APB F dr equal to integrate BA AQB F dot dr. Since the work required to move a particle depends solely on the dose point and is independent of the path taken, force is conservative. So this is the MATLAB coding for the question 3A1 Roman and 3A2 Roman. So first of all, we have to run the simulation. So in the command window, they say that theoretical interpretation and vector field cannot be calculated or properly shown in mathematically software. Please refer to manual or type solution for the understanding. And then explanation on same amount of work done by given force field to move a particle from a point A to point B for two different paths cannot be calculated or properly shown in mathematically software. Please refer to manual and type solution for understanding. So that's all for the question 3A1 Roman and 3A2 Roman. Is question 3b. For the question 3b, we have to calculate the following line integral in a counterclockwise direction around the diagonal path as shown in figure Q3b. So this is the figure. And firstly, for the MATLAB, so this is the question 3b coding which we write on the editor, and then we have to run the simulation to find the C total. So the result that we get from the command window is 1/2 for the C total, and based on the question we have to find the C total. So the next, so this is the graph that we made from using Desmos software, and which is for the C1 y equal to 0 and the C2 is x equal to 1, and for the C3 y equal to 2x. Next is question 3c. For the question 3c, we have to calculate the following line integral by using the theorem where c is the path from 0, 0 to 1, 1 along the graph of y equal to x power of 3, and from 1, 1 to 0, 0 along the graph of y equal to x. So for the question 3c, this is the coding that we write on the editor using MATLAB. So run the simulation. So the value that we get is 1/4. So between the value of software and the manual calculation that we get is same. So this is the So this is the final. So this is the manual calculation for the question 3C. We see we get the same value between the manual and the software method. And for the graph for the question 3C is this. So this is the graph that we using a Desmos. So y equal to s and y equal to x power of 3. Next is question 3D. For the question 3D, we have to find the work done by the force in moving an object from point -2, 4 to point 1, 1 along the curve y equal to x power of 2. So the force is given by F bracket xy equal to x power of 3y x minus y. So this is the MATLAB for the question 3C. For the question 3D. So we have to run the simulation. So the value that we get from the command window is 3. So the value between the software and the manual calculation we get are the same. So this is the manual calculation for the question 3D. So the manual calculation, the final value of the manual calculation that we get is 3J. So it's the same between the software and the manual calculation. And for the graph, so this is the graph that we use using the SMOS software. So you can, based on the graph, you can see that the line is assumed as a y equal to x power of 2. So that's all from me. Thank you.
Assalamualaikum. My name is Azri Ikhwan, and today I'm going to tell about question 4a. For question 4a, we need to calculate the surface integral of y square plus 2yz ds, where the sigma is the first octane of the plane 2x plus y plus 2z equals to 6. To find the equation for ds is ds equals to square root dz over dx square plus dz over dy square plus 1 dA. Next, we need to find z from the first octane, and we got 3 minus x minus y over 2. Then we need to differentiate with the respect to x and y. We got dx dz over dx equals to -1, dz over dy equals to -1 over 2. Next, we need to find the surface integral of y square plus 2yz ds. So we need to do the double integral of with the y square plus 2yz square root dx over dx square plus dz over dy square plus 1 dA. Firstly, we need to put the integral of 0 to 3, 0 to 6 minus 2x bracket y square plus y bracket 6 minus 2x minus y bracket square root bracket -1 square plus bracket -1 over 2 square plus 1 dy dx. We need to calculate all this, and we got double integral 0 to 3 and integral 0 to 6 minus 2x 3 over 2 bracket 6y minus 2xy dy dx. Next, we need to solve the equation of dy. So we put integral 0 to 3 bracket 3 over 2 bracket 3y square plus minus xy square bracket 0 over 0 to 6 minus 2x dx. And we got integral 0 to 3, 6 bracket negative x cube plus 9x square negative 27x plus 27 dx. Lastly, we need to solve the equation for the integral 0 to 3 like this, and we got 243 over 2, and lastly we got 121.5. Now I'm going to show the MATLAB solution for question 4a. Firstly, we need to declare function f equals to alias bracket xy bracket 6 times y minus 2 times x times y times brackets square root brackets 9 over 4. Next, we need to declare lower interval x, upper interval x, which is x min equal to 0 and x max equal to 3. Then we need to declare lower interval y and upper interval y, which is y min equal to 0 and y max equal to alias bracket x 6 minus 2 times x. Lastly, we need to integral to f x min, x max, y min, and y max. So we can run the simulation and we got the answer, which is 1 to 121.5. That's all from me. Thank you.
My name is Muhammad Fikri Birahimi and my matrica number is CE210207. So today I would like to present multivariable calculus assignment, and the question given to me is 4b until 4c. So as we can see, on the right side is software solution and on the left side is manual calculation. Okay, for question 4b, suppose that surface of the sphere x square plus y square plus z square equal to 4 and f x y z equal to 7xi minus zk. So the question asks how to find the divergence of f. As we can see, just simplify, put the value given into the formula d over dx 7x plus d over dy, which is 0, and d over dz negative 1, and then just do mathematical equation this 7 plus 0 minus 1, and we will get the divergence of f equal to 6. Okay, then for second, evaluate the following surface integral by using Gauss theorem, which is the given f and ds, and this is the formula for surface integral by using Gauss theorem, f dv, and then don't forget to put the limit, which is the first integral 2 pi until 0, pi until 0 and 2 until 0, and solve the equation until we get the final answer 64 pi. Okay, let me explain about software solution. Okay, this is first find the divergence of f. So just declare k equal to negative z, f equal to ijk, and then just put the value given, this one, and then just put a d over dx I, b d over dy j, c d over dz k. Then how to find the divergence? Just put divergence times f equal to a plus b plus c, and we will get the final answer 6. So the answer for software solution and manual calculation we get is same. Okay, for question number 2, 4b2, evaluate the following surface integral by using Gauss theorem. Okay, so the formula for surface integral, and then just simplify, put this m integral 2 pi until 0 and pi until 0 q, this one, and then just type flux equal to 6 times m times n times q, and we get the final answer. Flux is 64 pi. As we can see, the final answer is we get is 10, 64 pi with manual calculation, same. C. Verify the line integral and surface integral by relating them to the stroke theorem, where C is the circle x square plus y square equal to 1 on xy plane with a counterclockwise orientation looking down the positive z axis. f equal to z square I plus 2sj minus y3 y power of 3k. So the value of x is cos t, the value of y is sin t, and 0 is less than equal t is less than equal to 2 pi. And then just simplify, input the value given into this formula and put the limit 2 pi until 0, and then solve this equation until we get the final answer is 2 pi. Okay, for the other side, just input the equation into this formula and still put the limit 2 pi until 0, and then solve this until we get 2 pi. Okay, for software solution, the parametric equation is x equal to cos t, then y equal to sin t, 0 is less than equal t is less equal than 2 pi. And then just declare a equal to rt equal to cos t sin t 0, and then b d over dt a f 0.2 cos t, and then sin power of 3 t, then b negative sin t cos t 0, and then the final answer, put the limit 2 pi to 0, and then fb dt, and we will get 2 pi. So as we can see, the software solution answer is same with the manual solution answer. Okay, this is for the other side. Just put left hand side, and then we get this equation, and then put this equation, and then put the limit 2 pi until 0, 1 until 0, 2r dr, and then we will get the final answer is 2 pi. Okay, so the manual solution with the software solution is same. That's all. Thank you.